let Adam sort of introduce himself and basically and sort of review his sort of palmaris as where he's been since he graduated from Harper, and his life with well, prior to CLAAS and then with CLAAS and all the rest of it. I think we'll sort of work on the usual routine of either saving questions till the end, or if you sort of put them into, if you've got any questions, put them into the chat, and then we can go through them, call you up to sort of ask your question to Adam as and when we sort of get to that stage. So I think with no further ado, I shall hand over to Adam. I see we are recording, so we're all up and ready and going.
Perfect. Well, thank you very much, Simon. Well, hello, everybody. Yeah, thanks for spending your evening with me again, and thanks for the opportunity to have a chat with everybody here. Now, please bear with me. This is a new presentation I put together for this evening. So because of the lack of events, bits and pieces, yeah, so I thought I'd put something new together, a bit of a different background, perhaps a bit of a different angle on things that I normally am going from a sales pitch all the time. So I'm going for a bit of a different approach here. And yeah, so if there is sort of a bit of clunkiness about it, please bear with me. They should run pretty smoothly. So who am I? If I just click through here, if my presentation will work. Yeah, there we go. There's me on the left-hand side there. I'm stood at our new building at Saxon. I will go over that in a little second. But I graduated Harper Adams in 2012. And I was also employed by CLAAS actually as my placement year. So I've actually been pretty much all the way through. I did have a little bit of a sabbatical in Australia, which I'll talk about in a second. But yep, so graduated in 2012, and I quite quickly realized where I wanted to be, or what part of industry I wanted to be in quite quickly. Again, I enjoyed combines, and I've managed to need a career somehow. I always got told that yeah, you'd be driving a combine, or yeah, those jobs don't really come up at manufacturers very often. So I thought, all right, okay. Got told that quite early on in my school career that yeah, perhaps those jobs are very small market for those jobs. Luckily, I was very lucky, right place at the right time, and I've pursued my interest into a career. So yeah, I was very lucky from that point of view. I started at CLAAS, as I said, as a placement student, and that was 2009 to 2010. Fantastic scheme that they look after you there, and you get to see all sides of the business. You're thrown in at the deep end and off you go. I was lucky enough at the end of it to be offered a job, and I said, yeah, that's great, but I would like to see a bit more of the world before I settle in the UK. So actually, I was lucky enough to get placed in Australia. So I worked out in Australia for 3 years, working as a product specialist over there for the importer of CLAAS, based out of Melbourne in Australia, but I covered, my geographical area was the whole of Australia. So I was on the road a lot. I lived out of bags. I flew everywhere, drove everywhere, gained a huge amount of experience, field experience, met some fantastic people, gained some fantastic contacts. Lovely place, and often people ask you, why did you move back to the UK? Well, there was an opportunity. So opportunity being working at CLAAS UK, and I started actually coming up for this, my 6th year working for CLAAS in the UK. So the opportunity came up as a product manager role for CLAAS. I thought, well, actually, I hadn't worked full time in the UK, so I thought I'd jump on that role. That role doesn't come up very often, so when those opportunities are there, you take them. So that's how I've ended up working for CLAAS. My title is product manager. It's quite a broad spectrum of role across industry, that role. I get involved with all parts of the sales side of things. So feeding back market information, so first-hand information from our customers, farmers, and delivering that back into the factory. So liaising with them forwards and backwards on new innovations, new products going forth. And then there's the selling side of things in the UK. So presented machine in any way, whether it be at shows, events, training to dealerships. So from the sales aspect, any involvement with the presenting or selling of a machine I get involved with, but also making sure that they turn up correct. So making sure that all the ordering system is in place, our price lists and et cetera, are all done. We tailor them specification-wise specifically for the UK market. Obviously, we sell globally, which we'll go over in a second. So we specify them specifically for the UK market and also Irish market as well. That's my responsible area. So lots of background stuff. That's sort of little bits of my role effectively. I am based in the building on the top right of your screen there. That is our new facility at CLAAS UK. It's at Saxham in Suffolk, just outside of Bury St Edmunds, where I live. And we've got a very nice new shiny building, although I've actually been in the new part of the building for quite some time because we did it in stepped phases. So I saw the whole demolition of the building outside of my window, and then I saw all the demolition of the old building and construction of it all. So it was a big distraction when in the office. In there, we have two big showrooms. What we can see in the bottom left there, that's one of them. That's actually the harvesting one, which will be the harvesting one. You can see some tractors in there, and then we have a split between the two sides of the building. So you've got two big showrooms where we'll be able to entertain people and so forth. And then in the bottom right-hand corner, we have our new parts department. That's the most probably impressive part of it that you don't actually see. So buried in the back is this massive new parts department. Previous building had been outdated, so it needed some freshening up, that's for sure. Whoever's been to Saxham or previously been there in the past, it was time for a new building. It did the job, that's for sure. But so we needed some new buildings to make just life a little bit easier and bring us up to date in the UK market. It was one of the oldest buildings. The CLAAS group, if we look at globally, it was one of the oldest buildings. So it was time for a new one. And we've got a nice shiny building. Everything's still functioning, although I'm working from home. We are used to it. I'm used to working on the road, as you can imagine. I'm in Europe quite a lot normally, with various factory trips or customer visits or anything involvement in that, and then also traveling around the UK and Ireland as well. So lots of things I get involved with. But so that's a bit of the background, the meats of it. So if we look at the CLAAS group itself, the world of combines, so the world of CLAAS combines, bit of a crude map here, not the most pretty, a bit grainy, sorry, but it gives us a bit of an overview. Now, if I collectively look at, we're in a world overview now of combines for the CLAAS group. Yes, we sell tractors, we sell forage harvesters, we sell mowers, balers, but tonight we're talking about just the combine harvesters, the bit that I'm responsible for. If we're talking our world, the European world, where our headquarters or global headquarters are based in Harswinkel in Germany. That is where we have our manufacturing plant for our combine harvesters that supply our market. We also have other facilities I'll talk about in a second, but Germany also has the manufacturing plants where we build our more hard engineering works, where we build our hydraulic blocks, our axles, our track units. That is all done in Germany as well, just down the road in a place called Paderborn, very close to Harswinkel as well. When we're actually looking at the cutter bars, they're manufactured in Hungary, so not a million miles away from Germany, but all R&D and manufacturing for cutter bars globally is done in Hungary out of a specialist facility there that specializes in cutting units, and also the whole factory is laid out completely different to what you'd expect. A combine reverses up a production line. A cutter bar goes sideways. So it goes sort of the long way up a production line. So it's completely tailored and set up for cutter bar production. Likewise, it's as a Harswinkel is set up for combine production on the production lines. And actually this year, we're having a bit of a reconfiguration in the factory to streamline it. We're actually having to raise the roof to fit some new cranes and bits and pieces in there. So actually that will happen this harvest shutdown. That's in Harswinkel. If we look at the North American market, which we have been there for quite a few years, 1999, was when we first started to see the partnership with Caterpillar and the launch or introduction of the Lexion series into the North American market. And you may have seen some other colors floating around in the North American market. Now we've launched the green machines, so they're all the sea green, as you would be familiar with the European CLAAS colors. That they sit now in the North American market across America and Canada. So we have a manufacturing facility in Omaha, right in the middle of the central wheat belt. It's a very central point. I've never been myself, but it's meant to be a pretty impressive setup there in Omaha. But that is for the North American market. They do not ship harvesters back towards Europe. They are done for that market there. Other places around the world, so other places where we make combines. We have a place in Russia called Krasnodar, in Krasnodar. That's quite an impressive factory. It's because it's actually newer than Harswinkel's, newer manufacturing facility than the actual headquarters, purely because it's not as old. So it's been set up, I've got the year down here, I never remember when they set up Krasnodar. 1992, they started selling used machines into Russia. And 1996, an office, the first selling office opened in Moscow. And then 2005, they actually opened a manufacturing facility there. And in recent years, it's had a big update to 2015. We were one of the first Western companies to actually be into Russia. A lot of other manufacturers, like John Deere, Vardestat, they all have manufacturing facilities in Russia for that market in particular. So it's a big one. So yeah, we've got to be there to manufacture in there. We also have manufacturing facilities in China and also in India. Both facilities make locally made products for that specific market. Now, India is quite an interesting one. We've been there. There's actually 2 manufacturing facilities there. And they make a locally made machine, the Crop Tiger. It's a small, compact machine specifically designed for harvesting rice, but it is adapted for cereals as well. So traditional cereals, wheat, barley, and so forth. But it is a compact machine designed for that specific market. And that's sold throughout Asia, down into Thailand, Malaysia, and everything like that. China's an interesting one where we have a manufacturing facility there. And actually, we're just about to launch a locally made machine there. That's been the first machine that has had the CLAAS R&D team involved. So R&D team in Germany involved with the R&D team in China. Again, it will be it was actually badged as a Dominator, but it's got the internals designed for their conditions. We do sell and they do import machines made in Germany into China, but not in big volume. Some very big estates do want German-made machines, so they specifically order German machines. It's not big volume compared to if we look at the whole market of China. It's not the volume, that's for sure. It's quite specialist in that area. But we'll be concentrating on the UK today. Just to give you a bit of an overview, it's incredible when you start talking with people in the factory, where they've been, what they've done. And me as a product manager, my responsible area is the UK and Ireland, a small little island if you look at the global scale. But we all sit in the product management team. So I have my colleagues in France, Germany, Italy, Spain, America, Ukraine, China even, and we all join together as a team. And we discuss various points, feedback, market information, compare. So don't feel as if we're just segregated. Oh, you do your little bit. It's actually a full team out there. As we just have responsible areas. We all have the same goals, but we all have our responsible areas. So it's quite a nice network of people. You also get a bit of an idea and gauge of various bits and pieces, how things work around the world as well. So yeah, quite an interesting overview of where we get involved. So looking at the UK. Specific, yes, my specialty again, the UK market, where we sit. Again, I've sort of put a few bullet points here of various things. Again, looking at the UK market, combine-wise. So there is other manufacturers out there, obviously. CLAAS, New Holland, John Deere, Case, AGCO are the main. So that's the bulk of the market. There is also Deutz combines imported into the UK and Ireland. Very small numbers though. So sometimes they don't hit the registration numbers to be reported. Sampo, and there used to be a few versatiles as well, but they didn't succeed really. They didn't get an importer established correctly. So I don't know if this one machine exists anymore, but it may still be lurking around in Lincolnshire somewhere where it was. There's a few Sampos from Finland in the market as well, but again, small numbers. Predominantly, the Sampo market is the specialist. So for crop production companies, for trials plots, Sampo make a specialist system for those guys. There is also, I can never remember the name, the green coloured for the trial plots. They also are in there. Couldn't remember it off the top of my head to quickly put this one together. So yeah, quite a few manufacturers there in quite a competitive market, as you can imagine. If we look at the total market size, what do we sell each year into this small little island? We sell between all those colours, we sell between 500 and 600 units roughly per year, depending on how it's going. Now, interestingly, when you look at it, it perfectly maps wheat prices. So if you laid over wheat price with combine sales, not almost, but yet they map very close to that. So again, when we have wheat prices up, we are a little bit this year. We're starting to increase in our sales this year. Our last big peak was 2012. Perfect storm there, the good yields, and also good wheat price. So we had a bit of a spike there in 2012 with our volume there. Was there some questions I saw there come through, or is it me just imagining it there? If there is, I'm not picking up on them. I'm sorry. I know it's just people saying hello. Yeah, okay. Oh, there we go. Yeah, here we go. We've got the comment there from the actual the small plot combine there. Very good. Looking also at the market, yeah. So what do we sell into it? It's not just medium-sized combines. It's not just big combines. We actually sell from the very smallest up to the very largest. And people often say, "Where's the economics in selling something like a small little Avero?" It's small in comparison to the likes of our biggest flagship, Lexion, but there is still the market there. Not big volume, but there is 1-2 units per year. We still sell of our smallest unit, so there is still that market there, and that's roughly on a 200-acre farm that would go to. People know it's productive, but again, it's convenience as well. So there's lots of aspects when it comes to buying decision of a new machine. We actually look at what's being sold as well, and this has changed in recent years of the split of the market. So a traditional or conventional machine being a straw walker, and then a rotary or a hybrid machine, as we call them at CLAAS, is roughly a 60-40 split. So 60% are actually in the rotary market or hybrid market. 40% of those sold of that 500 to 600 units are of straw walker, so conventional machines. Interesting is the average header size. The average header size, so the cutter bar width is 7 meters. It's very close to 9 meters. Now, I've been asked these questions before, as in, have we reduced the number of meters being cut each year? So each machine, is it going faster through the field? We look back in history, it's not far off. If we go back 20, 30 years, we sold more volume. We had more volume through the market. It was around 800 units or so. Previous to that, but like 30 years ago. And actually, we look at feet of cutter bar or meters of cutter bar going through the field. It's very close to the same amount of meters cutting through the field as it is today, as it was 30, 40 years ago. Just the number of machines is less, but the width of the cutter bar is wider. So actually, meters being cut each year is very, very similar. So again, it's people often see one big machine, that's the way to go, but actually still the same number of meters being cut. So it's quite interesting when you look at that side of it. There is a trend to bigger. Very rare do we find a customer wanting to go smaller for the same amount of acreage. It's a bit like tractors. I've never found a tractor with enough horsepower. You always want a little bit more. Not always. There is economics behind it all, but the trend, if we look at the market, is bigger. So bigger and bigger is where we are seeing majority of our sales go. Also, our demand go, not just in the UK, but all across Western. The demand is bigger and bigger. So again, people wanting also just physical size, more efficient, more output, physically is what we see as the market trend. We actually look at a breakdown of the actual area as well, what we're harvesting. Wheat is still the #1 crop. 54% of all arable crops is the arable area, so there's other crops growing obviously as well. So still a very much prominent big market for combines in the UK. So yeah, again, it's sort of giving a bit of an overview, a bit of background of where we sit and how we present into there, or how we have the task of selling in there. So yeah, again, it's quite an open market. There's a lot of us, but yeah, I'd say it makes things interesting when we have that mix there. Going forward, so talking about, again, a specifically topic on the Lexion, so our largest machines that we make. We launch, and I will talk about the whole launch process and the development side of the machine, but we have to, again, so we know the terminology that we're talking about here. If I start going off on a random tangent, please write a message or something, because I'm prone to doing that. If we actually look internals of the machine, we can look at the shiny side panels, but that doesn't mean too much. Although they look pretty, it's the insides that matter. It's the threshing systems, and it's the separation area of the actual machine that determines the output of the machine. Yes, there is factors of horsepower, grain tank size, and everything like that. But it's essentially what is doing the work, what is separating the grain from that standing crop and putting it in the grain tank. It's the threshing and separation system. Bigger the area, the more output you have, is the easiest way. And in our little island, the UK, separation area is king. So more of that you have, the more output you can get. You've got more physical area inside the machine, the more you can get actually out of the machine itself. Now we have two versions. I've talked about it already. There's the hybrid and there's the walker. Now we've seen in recent trends, we've actually sold more of the hybrid machines than we have of straw walkers. Again, that trend to a larger machine. Now, the hybrid machines are a larger machine. They have more capacity, more output than a straw walker. But again, years ago, is the market going to drop off for the straw walkers? And people predicted yes, again, the volume is going to go down, but there's other factors in it as well. And actually it was made the decision quite early on in development process of the new Lexion that we were going to push the boundaries of the straw walker even harder than we had before. How can we get more output of it? How can we get to the next level of performance from a machine? What can we do other than putting a bigger engine on top? We need to physically change the internals of the machine. So when I talk about hybrid machines, I talk about, or that is the rotary category, or we talk about the walker category of machine as well. Both fall under the Lexion brand, and we have 1,000 series, 8,000 series, 7,000 series, down to 6,000 and 5,000. It's just numbering that we give the machines. There is a split in the CLAAS world of what we call a standard body and a wide body machine, which is referring to the chassis width of the machine. A 5,000 series is a 5-walker chassis, and a 6,000 series is a 6-walker chassis. So the internal width of the machine. The wider you have, the bigger concave you have, so it's got more capacity. That's the symbol. It's the same with the 8,000 and the 7,000 series. Again, so it gives you a bit of a background of actually what's there. If I bring up the timeline now, so the timeline of when we launched Lexion. We launched Lexion in 1995. This was a big flag waving exercise. This was a very big step for CLAAS. It was the first very large combine that we'd made, and it was a completely new threshing system. We'd never had a hybrid machine. We'd had conventional, we'd had tangible drums all the way through the machine, but we'd never had a hybrid machine. Hybrid being the combination of conventional drums and rotors at the rear. Threshing, separation, combining to have the APS hybrid the machine. Completely unique to us, and it was the combination of knowledge of parts and then also knowing our limitations. The limitations were the straw walker. It doesn't matter how much straw you put on top of the straw walker, it does not separate the grain. So it needs separation. So the APS hybrid was introduced into the market successfully into 1995. We saw a large growth in just market share, but also volume through the factory throughout those first 8 years of the introduction into the market. And we've sort of built on steps all the way through. So yeah, I put a timeline here of 1995 through to 2020. So again, I haven't put this year in, because we haven't done anything this year yet. Now, essentially, the chassis and the principle remain the same all the way to 2019. The average lifespan of, if we're talking all manufacturers here, average lifespan of a threshing system or introduction of a new threshing system, I say not the lifespan, but the introduction or new integration of a new idea, is roughly about 25 to 30 year timeline. So it roughly sits in there. From there, it generally goes into another model size of machine once the new updated threshing system is then introduced. So it's a long time in the making. Now, where we saw or started to see introductions, I've got two timelines here. We've got the actual models. So we've had various steps throughout the years. We've added more horsepower. We've put more area inside the machine. We've put bigger grain tanks on there. We put new technology in there all the way through. Essentially, we're fine-tuning the beast that it was launched in 1995. Although if you compare the 1995 machine to a 2018 machine, you see a lot of differences. Essentially, there's a lot of DNA that is the same. So we sort of reached our capacity limits with that chassis that we had, with that threshing system we had. Where did we want to go? We wanted to, again, I'll go into this on the next slide, but we sort of reached the technological chassis capacity of that machine. We'd added various things all the way through. So more automation on the machine. We added tracks very early onto the machine. Actually, tracks were launched in 1996. Again, first combine harvester to go out with tracks. And then various automation, the likes of Cruise Pilot, the automatic forward speed, GPS steering, Jetstream, and yeah, larger, bigger models all the way through. But we knew we reached our limitations fairly early on. So to give you a bit of an overlap of the timeline, what sort of links on to the next part of it is where we started to started the next project. So the timeline for the Lexion was the new Lexion introduction. So the Lexion 8000, 7000 series, 6 and 5000 series. The launch project started in about 2008, 2009. That is where pen started to cut paper. What do we want to put on our launch statement? What is our list of demands? Where are we going to be going forward? Where's the market going? So 2009 is when we started putting pen to paper, the concept stage. Before any steel or any welders were brought out the box, they started putting the list of demands together in 2009. Again, I'm going over them briefly here because I'm going to jump back into this development stages as well. It took till 2012 before the first field testing. There was other things before, and you again, we're looking at the stage of it. In 2012, we started to put machines in the field. So actually crop physical machines in there. Before that was actually more research stage. So you're still in the labs, so test benches and everything like that. So still internally, and then in 2012, it's a complete machine put into the field. Now, don't feel as if it's one complete machine. I'll go through the steps there. It's you don't just fabricate just a whole combine out of scrap steel and sell it at the end of it. Yeah, this is a very stepped process. 2019 was the pilot series. Pilot series is referring to, so again, machines in the field. The pilot series was roughly about 20 to 30 machines. Now, this is the stage where we're at final concept. So all features are decided. We're at milestone 2 in production level. So there's a lot of locked in there. It's the machine that you're going to see launched the following year. So lots of locked. Pilot series is more about testing the factory. Making sure we can actually make it. Do we need to adapt or move something around in the factory? Do we need a new fabrication line? Do we need some new tooling? One example, we needed to make a new balancer for the new threshing drum. We increased the size of the threshing drum by 25%. You need a bigger balancing machine. And also, how do you move these drums around the factory? So that it's everything like that is ironed out in 2 years before launch. So you're making sure that the factory is capable of it. There's a whole retraining of the factory as well to build these new machines, let alone new operators manuals. They're already way back in 2017 already been put together. We've got to train our service engineers on this side of things. That comes more at the 2018-2019 stage when we have a pre-series year. Pre-series year is a lot bigger volume. So these are full production machines going down the production line, nowhere near the one-offs made for the field testing or anything like that. That was back in 2019. So 2019 is the pre-series year. Then we go into launch phase. So we place a number of machines into the market. Our pre-series volume for the Lexion was about 250 machines put through the factory and placed with customers. End customers, they purchased them. So it's quite unique at CLAAS. We don't build for stock. Every machine that goes down our production line is actually built for a customer. So they're an incredibly complex machine with an option list, pages and pages long. It's a very expensive machine to have sat to build to a factory specification. It just doesn't exist. So every machine actually that goes down the production line is built to order for a specific customer. So yeah, they don't just get built and put into a yard and then modified for each market. They're specifically made for an end customer in mind. So let's look a bit closer into sort of more the project stage. How did we dream up the concept? So again, I put an animation there of a finished project, but it's sort of just as a bit of a guide. Where do we start with the concept? You need to build that list of demands. You don't just build for fun. We set out to build the biggest combine in the world. That'll be great. There's a commercial aspect to everything, obviously. And that then has a very strict list of demands built up from various aspects. It comes also very close into the research stage. There's the concept stage. We put pen to paper. We say we want to have this much performance. We want to be able to fit these wheels. We need this road speed. We need this grain tank capacity. And these are all fine-tuned from various aspects. They come from the likes of myself, market demand. So I talk with customers. They say, I'd actually like a really big unloading auger. It'd be really useful for unloading. Don't want to drive on my straw. That's a list of demand. We put that in there. We definitely will want that feature going forward. Likewise, we need a different belt configuration. We're putting more power through the machine. We must update the driveline. That wouldn't come from me. That would come from the engineering team. So again, that's their responsibility. I give a feature, and I let the R&D team work out exactly how to do it. So that's quite a nice thing I get to do. Likewise, we pull all information globally as well. So there's different ideas from North America to Australia, for example. There's very different conditions to then Northern Europe, in Denmark, for example. Very, very different conditions. So we need to have a machine that works in all conditions. We generally harvest between 20 to 30 different crops. There is more, but that's the bigger areas globally. So this machine needs to be able to handle all of those different types of crop. Again, another list of demand there, put on the very first concept sheet. So then we move into the research stage. Again, very closely, tightly with the concept. We go into, we got a few images here of customer focus groups. Making sure that we're on the right track. Again, bringing in tight customers that we know throughout the world, not just in the UK, but in France, in Germany, Australia, South America, North America, and pulling that information together, actually physically listening to end customers, what they would like, and then being feasible about it. Because if you sometimes let the imagination sheet go wild, they will dream of all sorts of things. But we've got to look and pull it together. So South America want some magical floating device for the rear axle. That's not relevant for Eastern Europe. That's not a feature that they demand. So again, it's pulling and being realistic about everyone's expectations. So we can all agree on we want higher road speed. We want a bigger grain tank. So again, we're narrowing down those sort of aspects that are realistic. and also feasible. So yeah, we've got to be able to build it, and we've also got to be able to sell it. Yes, it's great having all those options, but all the capability of it, but it's being realistic. And that comes from hard research, from knowledge, from internal knowledge of harvesters and researching and so forth, but then also from the end user as well. So again, it's all put together, big teams involved, bringing or pooling all this information in one place. From that, then we can get the welders out. This is sort of gets the fun bit now. We can physically start, first of all, starting with the concept, working always back to what is wanted, what is that list of demands. List of times be hard to achieve by some feats, but again, you have to stick or be realistic about some of them. So again, some of these pictures are a bit grainy. The top left one is actually the only one from actual hard R&D test rig. That there, what you can see is actually a full swath of straw. There's a company that we get to bring in. It's completely all crop intact, so the material is cut in field, and then laid a swath in front of the machine, so feeding into a test rig for the threshing system. Because this is the stage where we decide on sizes of drums, positioning of drums in there. And then that always relates back to that list of demand I keep talking about. So we say, oh yeah, this size drum works really well with this drum, but we're going to have to change a pulley if you want to adjust the speed. No, didn't meet the list of demands, gets culled. So again, it gets bounced backwards and forwards between two departments. This is what's capable. And then it gets pushed back. Nope, that's not what we want. So again, it's quite a long process of bouncing backwards and forwards. And then we've got some more examples of our field testing units. So more on hand. This is some of the delicate testing that you do on a small scale or end production scale for sort of marketing purposes. I don't have any of the hard test rigs. It's quite confidential sort of stuff, so we don't hand those out. From that side, from the test bench side, then we go to the field testing or the large scale testing. That is a whole different kettle of fish. That's where we start to see a combine put together. And I'll just jump to the next one. It's quite a nice image I've got of the machine here. This is one of the machines. There's roughly about 10 concept machines. So concept machines, we don't put all the new ideas in one go. So we don't put the new threshing drum with the new grain tank, and we don't test the new grain tank with the new drive axle. We don't test the new drive axle with the new straw chopper. There's two things going on and fine tuning needed from that side. So one thing, you develop a new threshing drum, which we did. Increase in diameter, that gives us the ability to have a bigger concave. Right, we're going to have to change the whole way that the concave sits inside the machine. Concave doesn't fit on the chassis that we had. We need a new chassis. And then you can imagine the steps involved in making all these nice new ideas work. You know, what we have here is one of the threshing systems being tested. Now, this is the 770 that you can see at the front of the picture there is the test machine, so actually harvesting. And then behind it is the test rig. So analyzing, it's all linked together. It's taking all the straw through there. So it's, again, testing its separation, testing its cleaning system. So there's two conveyors there. I don't know if you can quite make it out. One is taking a straw in at the top, and then the other one is taking the chaff and material off the sieve box. It can then fine tune the machine. So you know if you adjust something on a machine and test the speed ranges and everything like that. On board that machine at the back there is a whole array of testing equipment. Yeah, you can sort of make out some of the bunkering on top. They're all linked together, but they're driven. So you need the right size field for something like this. But there's a huge amount of data points that can be made in a very short period of time. You know, when you adjust something, you can test it backwards and forwards. So again, this is sort of the big end of things when it comes to actual testing combines. It's not something that you see very regularly or is shown publicly at all. As again, I chopped this out of some presentation I've had a long time ago, and I'm presenting it tonight. I like it. I think it's quite a nice image there. So you get a bit of an idea of what we do. And from those 10 machines, then you go to the next stage. The next stage of development is the production machines. So again, we've developed the ideas. We know how the crop flow works for the machine. We know how it responds in different environments. From that, we then start to build the full production machines. So there's pilot series, and before the pilot series, you have the R&D machines, effectively, which is the raw state. They are fully fabricated in R&D. They don't go down the production line. It's the ones you hear about or potentially see in the Profi magazine, catch it at a long distance lens, the far side of Germany. The machine was actually tested in over 8 different countries. The UK was a test bench. So we have a number of farms in the UK that these machines were tested at. Throughout the UK, whether it be a durability machine, so that's more at the end of the life cycle of the development, where you put as many hours on a machine as possible. Roughly, they put about 10,000 hours of threshing through these machines before they were even put through the production line. If you put 10,000 hours on a machine, a typical machine each year, actual customer would be putting on average 250 to 300 hours a year. So that's a lot of years worth of life put through the complete machine. There was about, as I say, the project was 10 years, but field testing was 8 years. And over that 8 years, we had 10,000 hours of actual threshing hours put through these machines. There was over 1 million hours worth of, if they put all the time cards in one sheet, there was well over 1 million hours of man hours put into this machine as well. So again, because there's so many different aspects, you're bringing in all levels of different parts of the company to bring this project together. And the task of the project managers, because you're dealing with so many different levels, is huge, and keeping the thing on time as well and delivering the end product. So for it to be able to harvest all those different crops in all different conditions in different countries, when this 10 years ago, the machine that is built today, the engine that it's got didn't exist. So how do you even start by putting that on the sheet? The engine physically didn't exist, so you couldn't even test that part of it. That was really late on. You have to make sure that all the driveline, the engine manufacturer itself supports this sort of environment that is going in. Then you design a cooling package. The cooling package alone is specifically designed for these machines. It's not just taken off the shelf. So there's so many different things. You can imagine airflow through the machine that has to be dreamt of, but can't be actually finished in the project line because the technology isn't there. If we look back on the timeline as well, we didn't know where engine technology had to be when this technology started 10 years when they first started drawing. That's why you saw quite a lot of model launches, and lots of manufacturers have had model launches in recent years, because engine technology has been changing and emission standards have been changing so quickly. I was having this conversation with someone at a different part of the agriculture sector today. As actual standards or law, we're one of the only part of the agriculture industry by law that has to abide by emission regulations. We actually physically have to. We can't produce these machines without abiding by the rules. So actually, when you're looking at that side of things, there's a lot of loopholes that you have to jump through to make sure that everything is working correctly and everything matches up and marries together. So yeah, again, lots of different aspects on the role itself. So again, you can imagine trying to push everything together like that is no easy task, and the number of people involved in specifically the Lexion is huge. It's quite an interesting when you start to, because we get to meet these people. They're not secret people tucked away in the box. We have real conversations with them. They sit in our meetings, get our ideas. So we have a really straight line level of communication between all levels of the business. Again, from each country to the R&D engineering department. So we have a very straight line level of feedback on all levels. So it makes things a lot easier. Communication always helps. And then we get into the fun bit. This is where I have to put my overalls on here and have to get involved with the launch. Now, again, the final concept this is sort of more my concept drawing here, sort of the tied up before launch. Often this side of the things gets overlooked. The amount of material that has to be put or collect together is quite incredible for a launch. So actually, when we launch something, we don't just say, "Oh, look, it's a nice, pretty picture. Here you go." We actually physically need to have everything ready. The operators manuals, we need brochures, we need pictures, we need sales presentations. We need to have training on these machines, not just for ourselves, but also our parts department need training too, because actually when we compare this machine with a previous machine, there's 90% change in parts. So the knowledge and everything in the background needs to be completely up to date before we get and launch this machine. So things like this animation here needs to be ready. So this is all going on in the background when the machine is still being worked on. So it's getting its finalized touching, the slightly tweaking some driveline or everything like that. This all needs to be working at exactly the same time. So hence why the marketing side, the service side, the R&D side, we're all working together for the same goal. And it's making sure every aspect of the business is ready. And we've also got to keep it a secret, because if you try and sell a customer a machine, even though you're on an eve of a launch, you do not want, always, no problems with that, but you don't always want everybody to know about your new machines. Yep, one competitive advantage, but also you've got to sell the previous generation as well. So we have to be quite internally strict with who we talk about, who we sell the machines to for that pre-series year. Yeah, there's a whole loads of background side of it, so making sure that everybody is on board on that. And again, something like this gives you a bit of this animation here. It's just quite a nice one that we use quite regularly to show some of the new features on there as well. But yeah, again, gives you a bit of a better understanding when you're trying to educate someone on what you've tried to. Why is it taking 10 years for you to make this? Well, it's not just a new sticker on the side of the machine. There's a lot of internal change. So again, some nice computer technology here to animations that we have to be able to explain. Likewise, I was talking about that new concave there. We've got a new feed drum there. So lots of things to make our life a little bit easier. And then finally, we have the nice shiny launch. Now I'll just mute this here because it is a bit loud. Final launch. Who do we need to launch to? We have a sort of launch stage. We have internal launch, which is what you're seeing here. This was where we took our internal sales team. This was actually done in Berlin, where they showed off the machines. Again, it was their first impression, their first seeing of the machine. You have to motivate, get them excited, show them all the new features. And that was done in Germany, in Berlin. So again, before we did our internal sales launch in the UK, we gave them the first view before we have any customer launches. You do an internal launch, then you have a sales launch, internal sales launch, then you have a press launch, and then you have a public launch. And it's make sure you have the different material for each section as you go forward. So again, it's from first concept to this, what you're seeing there on that video is it's quite a task, as you can imagine. The big machines, and yeah, there's a lot of moving parts to get exactly right, and the expectation in the market to make sure that it all works and performs is very high as well. And that leads me on to finally, again, probably you're used to this one in the wrap up of your presentations that you have, is where does the future hold? Now, I've put some of the past there. People talk to me about demounts, dual purpose machines. Surely that was something for the future there. Yeah, getting more hours on that machine. It's been done. And the specialist machines, it's difficult to make a specialist machine to be excellent at harvesting wheat, barley, oilseed rape, corn, soybean, rice, and then also demount it and it go ploughing. The machine that goes ploughing is the tractor, and that's a specialist tool as well. So perhaps, yeah, again, I'd love to see more hours put on these machines, more utilized, but personally, the way I see things going, it would still be a specialist machine to harvest crops. And then there's the other concepts. The top one is a concept there. There's plenty of concepts for combines for the future, whether it be like the Tribine that you see there in the bottom right with the sort of the rear tank, large grain tank on the rear, articulation. If anyone's driven anything articulated, difficult to steer with a cutter bar. It'd be a nightmare. But nice for going around corners and turning, but going in a straight line, yeah, be a little bit shaky, bit responsive maybe. But yeah, there are lots of different concepts, and yeah, sort of more opens the field up to where we think I can see quite a fair way in my role in the future. And yeah, I say again, of course, it's like saying, of course, we've got stuff in development now. It takes a long time to develop new machines and make sure that they're correct and meet the criteria of the customers. So of course we're developing new machines now. There's always development, and I always got told from the start, anything is possible you can imagine. So you think of a feature, anything you can imagine is possible, but it's how much you're prepared to pay, and that's always the hard part. Is that anything that we can dream of, whether it be a floating machine on a hovercraft, great, but there's other aspects. It's going to double the price of the machine. Ooh, okay, perhaps we won't be able to sell that one. Oh, electric drives is also a firm favorite in technology. Again, cost is a big one. So lots of things that could be, but then there's also a commercial aspect to it all as well. So again, it's great. Again, it's also with the development side. It's a bit like saying Apple will not launch a new iPhone. Of course they will. VW will launch golf. CLAAS will launch a new combine. So yeah, often questions that get asked are, what's next? And yeah, we can see quite a long way in advance, but a lot's going to change in the next 30 years, like it has changed in the previous 30, from small combines to incredibly large combines with 790 horsepower. So yeah, who knows what holds for the next 30 years, but or even 25 years, the life of the Lexion. It should be interesting times, that's for sure. So that's the end of my formality, as in that's the end of my slides. I sort of built in a bit of time, sort of structured it in a bit of a way that maybe there'd be questions. I'm not sure how you sort of normally roll out of this, but yeah, say that I'm all open for questions. If you have some specifics, you've been writing notes all the way through or something, I won't be checking. But yeah, but thank you very much, guys.
Okay, thank you very much there, Adam. That's absolutely superb presentation. On my screen,
I can't hear you, Simon, if you're talking at me.
You can't hear me, you say? I would say that there's one question come up on my chat screen from Mike Whiting. Do you want to unmute yourself and ask the question, Mike?
Sorry, it might be just me here. I'm just actually looking through if you can still hear me. Yeah, again, I'm not sure exactly if there's someone talking there, but just going through the questions here again on the chat there. Sort of a bit of one with the value of straw being a factor in overall crop value. How does it fit with the straw walker versus rotary design? It's a good question. Again, I've talked as an overview of the Lexion, and very much at the very start. Again, one of those listed demands I talked about was to push the output of the straw walker machine. We reached a level. You reach a level with a straw walker machine, and that is it. This has been very steep losses afterwards. We needed to introduce a new threshing system to gain more capacity. So yes, actually, we're seeing the split is almost 50-50 this year in sales. We're actually seeing more sales in straw walkers than we would perhaps previously, purely because we've reached the gap, bridged the gap between rotary and straw walker. The largest walker machines have very close to the same output as the smallest rotary machine. And yeah, a good factor there is straw prices are high, the demand for straw is high, and yeah, so if you can increase straw yield by protecting it, by being gentler on the straw versus more aggressive, then yeah, there is a demand there for straw walkers. That's for sure. It's not a dead market, which some people predicted. Why does CLAAS use horizontal track format compared to triangular track format used by John Deere, AGCO, New Holland, etc.? Yeah, there's lots of, again, I can get my full sales hat on here if you like. Lots down to the design. The track specifically designed for harvester. Now, it's been the whole way through from that side of it. There's lots of sides of it, but there's no short answer here. The pivot point is one, and we're not designing a track. So again, you sort of look at the John Deere 9RX, triangular track. It's got to pull a machine through the ground. It's got to pull a big cultivator. This is not the case with the harvester. It's got to provide one, a nice big footprint. It also needs to provide suspension, because actually if you have a rigid track on a machine, it's very aggressive. It shakes it apart. You need a bit of a different setup. So actually our machines are suspended on tracks. It's difficult to implement a full suspension system on a triangular track. We know that because you need to keep it tensioned. It's not lug driven, it's a tension driven track. Yeah, there's lots of different aspects to it. Effectively is the pivot point. It's keeping the surface contact there for longer. If you have the pivot point lower, you get in less articulation, so more driving force lower. I can go on and on, probably do a whole another evening on tracks if you'd like, but yeah, perhaps I won't get stuck on that topic too long. Essentially, they are track systems though, and a track system will do very similar role. What is the cost difference between a rotary machine and a straw auger machine? Now, a rotary machine is more expensive. There is more componentry, more driveline, because you have two speed differentials. You have a drum, and then you have a rotor at the rear, and they have two different speed ratios. Also, the transition of crop is a lot more technical. Splitting material into a twin rotor system, delivering it. Also, rotor grates underneath. It requires a lot more engineering behind it, because there's actually a lot more forces in the machine. You're pushing more material for a rotary as well. So being able to have heavier drives in that aspect as well. So generally, yeah, the rotary is a more expensive machine because it has more componentry on it. There's more technology inside of a rotary or a hybrid machine than, say, a straw auger machine. With the 2015 net zero emissions deadline, will you be having a look at EV type design vehicles? Now, difficult one. Of course, it will be looked at, and there will be a commercial aspect of it as well. Now, yet you got to look at it and be considerate of it as well, because at the minute, of course, it's been looked at with electronic drive, electronic motors. Again, the possibilities there, not with current technology on this size of machine. The space required for various bits, yeah, could work. Of course it could work, but some of the technology is very expensive to make all componentry on this machine work. So again, I'm not ruling that out completely, but yeah, for sure, it will be looked at. What do you think the future concept will be, Adam? Biggest, faster, larger, or smaller, robotic, automated, or for longer operation? Now, again, I think I've ticked a few of the boxes. Are bigger. Have we got bigger? Yeah, again, always looking to get bigger. So on my opening point, I still haven't found a tractor with enough horsepower. Doesn't matter the application, you can never have enough horsepower on it. It's probably my farming roots. Bigger, yes. But we're not forgetting the small market as well. And now, again, you feed the technology up, you make the new biggest. That technology from the previous generation still remains. So by no means is it just all big, big, big. Actually, that market globally is quite small for our biggest, which we call the 8,900. Globally, that is not the volume market. The volume market is the mid-size machine. The 7,600, which is a mid-tier hybrid machine, is the volume. So yeah, not always the biggest is the highest volume. But will we see bigger? Yes, we will see bigger. We will see wider headers, that's for sure, in the future. More automation. We have developed automation on the machine, but we will get smarter and more of it. We're at the sort of stage where they launched auto contour. So auto contour on the Dominators. I don't need auto contour on that machine. I can do that myself. I'll fall asleep. I can level the cutter bar myself. Don't really need it. We're at the same level with automation on our machines now. We have adopters, and we've got sort of more the old way of thinking, let's say. So as time goes forward, we will see more and more automation on machine. already we have a system called CMOS Automatic. We've got Cruise Pilot. There's all manner of automatic systems on there. And we're seeing a good adoption of it as well. People seeing the benefit of it, a bit like GPS steering. Yes, it's or an automatic steering. It's close to now 80% of our machines going with an automatic steering on there. You take that back. When we launched the Lexion, automatic steering? No, we actually launched autopilot, which was to follow the maze rows back on the Dominator, I think it was. And the adoption was slow, but where we are now, yeah, we're at 80% take rate on an automatic steering system. So yeah, more automation definitely in the future across all aspects, not small, but perhaps adding more automation to a smaller machine, making that small machine more productive. I could tick a few boxes. Certainly in the UK transportation, width, height, mass is a limiting factor. Yep, correct. Design factor. How the class see future design in terms of continuing increase in output and productivity? Yeah, a big one. And each, this is always fun because each country has different rules, different lighting, different weights, different axle loads, different speeds on the road. So again, from my class point of view, it's a minefield being able to transport them around. You think France is a lot lower road speed, 20 kilometers an hour for over a certain weight limit. Likewise, Germany has different restrictions. Then America has different restrictions altogether as well. Same as likewise with the UK. It is a big design consideration. Yeah, it's all well good making the biggest combine, but yeah, you need to get it around. Width restriction already has come into play with these machines, so being able to keep them at 3.5 meters. We've actually increased the transportation speed on the machines, but you don't need to be driving at 40 kilometers an hour. It's always the argument of buying a Porsche. You don't drive it at 200 miles an hour everywhere. You stick to your local road regulations. So yeah, again, we might make them faster, but it might not be used the whole time. So yeah, it is a big design criteria, is being able to get them around and transport. Hence why we have taller, bigger tires, with higher speed transmissions, safety systems involved. So if the hydraulic system was to fail, there's backup supply for the hydraulics, so you can still steer the machine. Everything like that. So yeah, it's all built into part of the regulation of being supply machines globally. I got a problem with my speaker. Okay, yeah, maybe do. I'll see if that has fixed it at all. Might have muted it there. Is class looking at next generation power source? Again, we are not an engine manufacturer. We have made engines in the past, but we are currently, of course, again, probably taking my class out of now, I see hydrogen being the most exciting and most forward-thinking way of the future of fuels, especially in this sector. I see hydrogen being a big factor coming into play at some point. That's my opinion on it. Not that I've seen a hydrogen-fueled combine, but I've seen plenty of hydrogen-fueled engines and various industries adopting it as well or testing it. So again, I do see hydrogen as a fuel of the future. Might be wrong, might be in my words, but it's what I see as from my point of view, perhaps more my personal point of view. Noticed in a couple of slides that your header reel has a slip in 2 parts. Why is this done? You mean the overlap? Yeah, split. Yeah, that's a good point. People often ask that. Actually, making one piece 40, 45 feet or 13.8 meters, 12 meters, you get a lot of flex in it. We've tried it as a single piece, and it's getting it rigid and strong. Those reels actually need a lot of force in them. So there's a huge amount of torque actually required, especially in laid crops. They're a very powerful reel, very high power hydraulic. So they need to be strong. If you make them single piece, they bend with that amount of crop that you're trying to dig or pull through the machine. So you don't use it the whole time, but if there's a laid crop situation, also if you're harvesting things like rice, real dense crop, real wet, or grass seed, for example, you need to pull it. So hence why it's a single split. I hope I'm going through this quick enough. Sorry guys if I get stuck on something. You can try again. I might be able to hear you now if you want me to, but Powder future, important considerations are surely energy density and commercial viability in practical terms. Correct, yeah, it's always commercial viability is a big tick there. That's a good scapegoat on pretty much everything I say. Do you think there is a limit to the possible development of Lexion within the UK market size engine power? No, I don't. I can still see things potentially wanting to get bigger. We've made a pretty big combine, but you still take it to a big customer operating two of them. I'd just quite like to run one. Or they're looking to do something different. There's lots of aspects. We don't just sell one. How much area do you have? You have this combine. There's too many different factors involved in the whole selling process of a combine. So, yeah, it's not one size fits all. So, yeah, again, I think that there will be development there. Not a case fan, but just wondering if other manufacturers have come out with this hybrid system in order to combat the case rotary patent, or is there actually a big benefit in a hybrid machine? So, yes, there was, and there is. Massey Ferguson actually made a hybrid machine. They've discontinued that, and Sampo have launched a hybrid machine this year as well. So, 2 years ago they launched it, but I think it's only come to market now. So there is other manufacturers that make it. It's complex. It's difficult to make. Again, quite a few years of experience there of making a hybrid machine. It's not as easy as just putting some rotors together and some drums at the front. Splitting that material in all different conditions, feeding it, getting performance, getting grain quality. It's not an easy process. It's a complex machine. There's more componentry involved compared to a single rotor, for example. So yes, there is complexity there. The single rotor concept from CLAAS is an old concept. Yeah, it's not new. There is other manufacturers that make single rotor machines as well globally. The biggest combine manufacturer in the world makes a single rotor machine, John Deere. They sell more combines than anyone else globally. So yeah, again, that's not by any means. It's no easy feat to make a hybrid machine because it takes a lot of time and it's expensive. With the combines and self-propelled forage harvesters coming from Harswinkle, how much of the resources and parts are shared between them? Are there in similarities? Yes, we've taken actually the driveline, the clutch engagement system from the driveline from the Jaguar this time round. The Jaguar has always been a very powerful machine, a huge amount of horsepower, huge amount of torque going through them. They're a more powerful machine than, as in power-wise, than a combine. We've reached that level of horsepower now with combines and the torque going through the machines. So we're taking some of the proven technology that we've had from the Jaguar, and we've pushed it through into the Lexion as well. Main one is the drivelines and the experience there. The boys, the engineering team, shouldn't refer to them as boys. The engineers on the Jaguar side of it, very clever in the way they transfer power through the driveline. Again, it's incredible what they can do. Almost 1,000 horsepower through a belt. It's quite impressive. So we do share the technologies through them. Not many common parts. Don't have a threshing drum or anything like that, but engine things like that we do share across some platforms. Does the research and development team look into new materials much? Yes. Lighter, yes, absolutely, of course. Perfect example is reel tines. Plastic reel tines. You can make them longer. You can make them wider than the steel one. So that's I know it's not much of a technology. Also, the side panels. Side panels got changed. They're not a steel side panel. They're a composite sandwich material. Again, we actually made them lighter because big heavy side panel. Don't imagine making them out of steel. It's hard and also adds weight to the machine. So of course, new materials are always experimented with for wear, one thing, but also making them lighter, stronger, more robust, of course. Thinking about big versus small, automated. I think I might go as mitigation measures to soil compaction, not just about market segments. Correct? Yeah, that's more adoption potentially through control traffic farming, so forth. Potentially, again, the weight if someone, you got to, again, there's perhaps a material question. Trying to make them lighter is always difficult, because if you make something lighter, it needs to have it can be more expensive, but it also can have less wear, so forth. So always a compromise there. But adoption of controlled traffic farming is actually, the UK has, if I look at class sales of controlled traffic augers, which is the load auger to match up with the previous run where the combine is, so the tractor always drives where the combine has. We've got the largest market outside of Australia. So globally, the UK market is a very strong market for controlled traffic, and it's a very big consideration for most large combines. Most are doing it. So yeah, it's, again, is a common one. Would you like to comment on the concept of selling a harvesting solution in terms of cost per hectare, as opposed to selling a big shiny machine? So yeah, that's generally how we sell. We generally sell cost per hectare to a customer. So we break it down on cost of ownership. Total cost of ownership is a hot word that a lot of customers, a lot of manufacturers use. We break down the running cost. We break down fuel cost, efficiency, resale value. How much is the purchase price versus the resale value? All factored in, we put it into a calculation, and generally we work it out cost per hectare, and we have criteria to meet, so we can also include our servicing cost or fixing prices there. So yep, that is a very common way that we talk, is in cost per hectare, rather than just £500,000 for a combine. It's a hard pill to swallow, that. How important is expanding range of CLAAS products into tractors, implements, etc., base sales, market share, mainstream products of combines and foragers, such as ecosystem products like JD or Apple? Okay, so I'm not sure what you're telling on that question there, but market share or volume of all products, yeah, again, we look at our mainstream harvesters. So we look at combines, we look at foragers, and in-house machinery, incredibly important to us. We have specialist factories. We've got whole departments like our tractor team, from the Zarian through to the Atos. Incredibly important globally. That's why we're introducing the likes of our Zarian. Very successful story of the Zarian, actually, in the North American market there. Likewise, the tractors into Asia. Yeah, really important part of it. All aspects of it are important, and all contribute to the business growing. Technology can be passed sideways as well. There's things we learn, or automation we learn on the combine, we can pass through into tractors as well. Is the 2-engine combine out there? No. There was 2-engine forager, but that got discontinued. So yeah, but we only run single-engined machines. I'm not aware of any out there in the market. So there might be some home-built ones, but no production ones. Yeah. Good. Right. Sorry, Simon. Do you want to try again and see if you can, if I can hear you now? I might have had my my computer muted, so I do apologise if I've been talking away and people have been trying to ask questions.
Well, there's you've got the list of questions I had. There's a couple just come up. Paul Hemingway has, in fact, there's 3 more come up since the 2-engine combine question.
Yeah, I see them there. Yeah, are there any design aspects or aspiring goals for Lexion line which have taken the most work, or has been difficult to reach such an endpoint? Yeah, again, I know, speaking with the R&D team, again, it wasn't easy from the list of demands that we gave them, especially what the machine that you see there I've put up. The straw walker was the biggest challenge. How to get more output out of a straw walker, and maintain the straw quality, maintain the grain quality, also having all adjustments from the cabin, likewise, the whole package. I know there was a lot of there, and the adjustments and angles. So again, I remember seeing a picture of all the different accelerator drums that they experimented with, and also all the different angles and ways that they can adjust the rigs that they made to fine-tune the crop flow. Again, no easy task there, other than, yeah, it's big pieces of steel that you've got to bolt in and out and change and adjust and test for hours and hours, and then put the durability on it and make sure that that works, and then put all the different crops through it at the same time. So yeah, huge amounts of complexity in developing the crop flow, that's for sure, and get it getting it to work in all conditions. So yeah, I mean, again, there was no easy one. Things like grain tank size, yeah, that's make bigger tank. That's tick. Make sure they don't fall off. Tick. Make sure that it holds all the grain. It's them the more easier aspects of the job. It's more ensuring that the cooling system pushes material away. It's how things fold in or integrate with one another. That's the harder parts of the design process. In terms of yield mapping, how is the resolution going to improve as headers get wider? Good point, and that's often a topic we discuss. Difficult to get the right resolution of yield mapping. As we go wider and wider, there's scope for more inaccuracy. How do you determine yield from one side of the cutter bar to the other side of the cutter bar when you're pulling 45 foot, 30.8 meters into one hole? Difficult. So you have to increase the refresh rate. Now, we're increasing the refresh rate, you get a lot of overlap data and so forth. Now, this is a whole different topic in itself, maybe, but I don't want to get falling down this rabbit hole. But increasing refresh rate is one thing, but also making the yield monitor more robust or less susceptible to variations is probably the better way of putting it. So new design of yield monitor, not a vision-based system, a mass flow sensor, pretty proven technology, but it's less susceptible to slope, less susceptible to wear in the elevator, for example. It's probably making the sensor more robust, so actually what's going through that physical machine at the point more accurate, and also making it easier for the operator to use. That's probably where majority of the errors have come from, is perhaps maybe operator error. The systems work, but it's perhaps making it easier to use and more robust. So that's where we'll see the biggest gains in accuracy of yield monitors, that's for sure. I hope that makes sense. If you have another question on that, please ask. With the high capacity cost of these machines, did I answer this one? Sorry, I think I did. Lower hours annually. Okay, no, it's a different angle. Do you see a model where you will no longer sell combines but lease them on the basis of charging per hour? This model has already used Rolls-Royce with their jet engines. Yeah, correct. Power by the hour. Yeah, again, there is a manufacturer that actually sells power for certain times of year, so you can upgrade your power on the machine. It's not going to work with drive lines, life of drive lines, but that's not the different topic. We do different ways of selling combines. We don't just do outright purchases, of course. We do it on contract hire bases, which are based on hours. So based on a 300 hours per year contract, all one fixed price for everything put in. So servicing cost, the only thing you need to put in is a driver and some fuel. And then you pay us one price and we take it away in 3 years' time. More specific hourly charge, difficult, because each harvest is going to be different. Every requirement's different. So you get difficult. I'm not saying I'm ruling that out for the future, and potentially there will be a roaming fleet maybe in the future. I can see where other industries have gone. We may rob something like that of big farm, doesn't need the capacity all the time. He's got a lot of spring cropping, so he's getting on early, so his rotation's changing. He only needs a big or multiple combines for his wheat harvest. And so perhaps having a roaming fleet that you can hire per hour, maybe, but not just yet. The economics currently aren't there. But yeah, again, maybe something like that we'll roll out in the future as, cost sharing and so forth will go down. Is there a ground pressure limit for preserving soil compaction as a function of soil type? Not on these machines. There's no way of measuring the soil pressure on these machines. We've had tire inflation systems fit to the machines in bits and pieces as a consideration. So when you drop into field work, it drops soil pressure down to the maximum amount, so as in the load carrying amount on the tire. But hey, it's difficult to actually measure the soil pressure in front of a machine, or what actually the soil pressure is. So to answer your question is no. Other than we've done plenty of research into bigger footprint. Biggest footprint is where you can get away with of the weight. So again, it's a consideration. Hence the big uptake in tracks in the UK market. Again, if I look at the Lexion market, we're up around. It's even more. So it's about the 70% of our Lexions are sold with tracks. So again, big combines are sold with track units. And if we look at our total sales, of combines in the UK, it's 90% of our combines go with tracks. So it gives you a bit of an idea of the scale that we sell with track systems on. History. Will ever increase horsepower? Does that say? I think we're already at quite a high horsepower. We go up to 790 horsepower. I've completely lost that question now. Where was that one? Sorry. Increase the horsepower of tractors. Do you see the return of trailed machines? No, I don't currently. For trail machines, they reach their limitations. The big, bulky, they have the limitations. Hey, they might work for certain markets and certain areas, but not on the sector where we see you see European conditions going. Are alternative header cutter bars available? Stripper headers, for example. Yep. We don't make a stripper header. Shelbourne do. They're the world leaders in stripper headers. Actually very close to CLAAS UK in Suffolk as well. Yeah, we do not make a stripper header, but we make a lot of different type of headers. We make ones specific for sunflowers. We make ones for picking up windrows. We make ones for flexing for soybeans, whether it be a draper style header or an auger type header, both in flex. Depends on which part of the world you're in. Do you want an auger or do you want belts? We make corn headers as well, so folding or rigid, various different widths of corn. We can, again, I could probably have a 5-hour conversation about corn width, row widths on harvesting corn as well. So yeah, there's a huge amount. We have a huge array of headers to match everything. Although we don't see them predominantly in the UK, we see the new type of draper header being in fashion or being wanted this year. Being able to flex, so wider headers, being able to flex, so contouring along the ground is better. Picking up laid crops, picking up lower lying crops, for example, soybeans. Our cropping is changing in the UK. I'm having more and more inquiries every day about harvesting grass seed more. It's nothing new there, but more people want to do it. Harvesting corn or maize, I should say. Lupins, soybeans as well. Soybeans quite low lying grain, so yeah, the flex cutter bar is required there. So yeah, again, lots of different types of headers, but we don't actually make a stripper header at CLAAS. Do you see many Douglas Bumford Trust scholars in the meeting? I can't answer that one, sorry. How close are you to autonomous grain collection? Yeah, difficult one, that one. It can be done, that's for sure. Now it's making sure we're consistent. So we have an automatic loading system on our foragers, for example. We've had for quite a few years. So the spout just maps out the trailer as an image, and it can see its box, and it can see how full it is, and it moves the auger backwards and forwards. So yeah, the one side of it, there is also the speed control. Got automatic speed control. Everything, all the componentry is there. So yes, it can be done, let's say. Probably leave it at that. Is there any development in using tracks in combination with Montana system? No. The track system will not work with a Montana. You need, for a hillside machine, so if you're not aware of what a Montana is the model that is a hillside machine. So it's got a leveling compensation on the chassis. In the UK, we sell one on the front, and so it goes sideways. You may have seen them, keeping the machine level. It requires the tire to flex, to grip to the side of the slope. A track is rigid. It doesn't flex sideways, so it doesn't fit with a hillside machine. Otherwise, you'd just be using the edge of the track, and there's a lot of weight and pressure there, and you wouldn't be really getting your benefit there. So at the moment, no design consideration to a Montana with tracks. Sorry, Robert. Yeah.
Okay, I think we've just about exhausted the questions now. I came in for sort of a second half there, or a second breath, as you might say, another flurry of questions, which was good to see. So I think with that, thank you very much, Adam, for your most excellent talk, and that informative,
No problem.
as ever. There was one question which I'm going to pose. I'm going to use my sort of chair's prerogative, as you might say, in that I've had an inquiry about the timing. This is a question back to the student members of the audience, and it really sort of is, what sort of time of day do they prefer for these sort of presentations and that? And if you could sort of email me, is probably the easiest way of sort of doing it, rather than doing it over this this forum and that. Just sort of get an idea as to whether this is completely for something different, whether the sort of 7:30 start is your favorite time, or whether it's earlier or later, or whatever, just to sort of as a straw poll, as you might say, really. So I think with that, I think we can sort of basically call our meeting to an end. Obviously, we're going to, let's say, reiterate my thanks very much to Adam, and we'd sort of show our appreciation in the normal manner, but in these sort of times, it's usually either some sort of one of these sort of little hand clap reactions or something of that to sort of say thank you. But thank you very much.
Yeah, well, thank you very much, everyone, for joining. And there's some great questions there. Always, again, it always changes the dynamic as well. Can't cover every topic, as you can probably imagine. I like to talk about combines all day long, but yeah, again, you've got to draw the line somewhere. So yeah, but yeah, no, thank you very much, guys, and have a good rest of the evening. Thank you.